All right. I realize that I start just about every lecture with those two words. It's a way of getting people's attention, I suppose. We have our sprint due on Sunday. I am not getting a study guide to you today, so there is no quiz a week from today. As I talked to some people before class, the reasoning for that is that we're going over design patterns that have not historically been part of this class. So I need to do some analysis on exactly what quiz 3 should cover, exactly what quiz 4 should cover, and make sure that we cover all of the quiz 3 content before we take another quiz. So it'll probably be a week from next Thursday, 2 weeks from today.
We're looking at just 2 more quizzes in the quarter? Or
Yeah, 2 more quizzes in the quarter, and there's no final, so they all happen before finals week. Because the finals period will be presentations for people talking about what they implemented, showing it off, etc.
So that's part of our regular sprint, right? Like before, or is it gonna be something extra special?
So there's the 4 sprints,
Uh-huh.
then there's a final code submission. And as you're working on that final code, between when sprint 4 is due and that final code, that's when your presentation. There are no additional requirements for that final code. It's just an opportunity for you to fix issues with sprint 4 and then get regraded with those improvements.
So we still have to present like at the end with everything that we put together.
Yeah.
Everything that is supposed to be
The
fixed.
actual, yeah, the actual UML editor, at the end of 4 sprints, you're gonna kind of have a demo for the class, not the client.
Oh, we're gonna be talking in front of the whole class?
Yeah.
Great.
I know, introverts love this.
Yeah.
Imagine having to do it for a living. I'm an introvert and I stand up here and pretend like this is normal and natural.
No, you're a natural talker, man. Don't mind.
That comes from experience. That doesn't come from
Yeah.
loving that. Believe it or not, I was the kind of student who would just visibly shake when I had to do a presentation, even for undergrad. There's something about having to be up in front of people for a living every single day and just making a constant fool of yourself that you start to realize, oh, this is normal.
This is normal.
And it's also an opportunity for people to laugh at you. And college is already hard enough. If part of your day is just letting people laugh at you and getting a little bit more enjoyment out of their day, that's a positive interaction that we can share together.
At you or with you?
Either. It doesn't really matter. All right, so last time we talked about the creational and structural patterns. I guess we talked about creational 2 times ago. We need to go over some behavioral patterns because we need to get to one that we're going to use for one of the requirements for sprint 3 that the client talked about yesterday. We'll see if we get there in the remaining 14 minutes that we have.
Behavioral.
So yeah, I guess we can talk about behavioral in general. So we talked about how creational patterns are responsible for object construction. Structural patterns are for the actual structure between patterns. So a lot of interfaces and how interfaces are used to delegate responsibility, to explore the expansion of objects within objects, the structure of sub-objects into larger objects that help for further design scalability. Behavioral patterns talk about the responsibilities of objects. What is the purpose of an object? Do you have an object that's doing too many things? In which case it needs to be split up into multiple objects that do fewer of those things in ways that now there's some scalability, because when one of an object's 5 responsibilities needs to change, there's a lot of code that needs to change around that. Whereas if each object is responsible for one thing, then there's less code that needs to be changed. And it's more structure, easier to see what the associated modifications should be. All right, chain of responsibility. We have a chain of handlers. I like to think of this as kind of a game of telephone, except that when it's a game of telephone played with humans, there's data loss at each level. When there's chain of responsibility between objects, you're not going to have as much data loss. So being able to break this down into the associated ordering. So working on an online ordering system, restricting access to the system so only authenticated users can create orders. Users who have administrative permissions must have full access to all orders, but these checks have to be performed sequentially. This makes sense. In order to make an order, you also have to be able to authenticate. So to authenticate an order and administrative permission, those should be checked in sequence rather than at the same time, because you can only check one once you have the answer to the other. So authentication and authorization as two separate tasks. You can imagine having one class that does both of those things, but what if you wanted to develop them separately? It would make more sense to split those requirements up between two different classes. And then when the request comes in, have one class handle the authentication, the next class handle the authorization. And then once authentication and authorization have been done, then allow them access to the ordering system. But if one of those two fails, disallow. When you have a chain of responsibility like this, it also is a little bit more secure, because if one change happens in one class that allows as some kind of security vulnerability, you have to get through both classes. In order to do that, it allows you to kind of split up that responsibility so that you can check for vulnerabilities at each point along that process and not just have one object responsible for the whole thing, where if that object fails, then the whole thing fails. So we'll implement several more sequential checks over time. And you see that as this starts to scale, that there's a ton of interdependency in the validation and caching. And it becomes very interdependent, where each of these classes relies on, has a different associated what classes need to have finished what before we start, what objects do I need to notify that I've completed this process by the time that it becomes a very crazy web. So implementing a chain of responsibility has associated handlers for each portion of this logic. So instead of having this long system, you would have handlers that are responsible for every sequential set of actions. You turn something that is a mess of a web into something that is linear and scalable. The result from one handler will be passed on as the input to the next handler, which does that handling work. The result of that handler becomes the input to the next handler. So we can end up seeing that something like, here's a branch of an object tree, we go from a button to a subpanel to a panel to a window, and that allows when a button is clicked to associate the chain of responsibility all the way to the display of the window of what happens when that button is interacted with. So you have handlers for kind of an on-click of the button, an on-click for a change, or a change in the subpanel, a change in the panel, a change in the window, creates that chain of responsibility. So handler classes need to implement the same interface, which is important because they all need some kind of handle functionality. Real world analogy, going through tech support operators, I'm sure we've all experienced this at some point or another, where you call into a call center and you get someone who's not authorized to make the associated changes to your account that you need. So you talk to, after convincing them that you need to talk to their manager, you talk to the manager, and the manager still can't handle what you need. So you go to their boss, you go up the chain of responsibility until you find someone who can actually handle that request or has the level of permission to handle that request. So it's very similar. You have a bunch of different handlers in the associated code where the lowest level handler has a certain level of permission. The highest level handler has all of the permissions. And if you're able to get through all of those handlers, then it keeps the highest level handler doing the minimum amount of work. So structure, we have our handler interface, we have our base handler, and then we have some concrete handlers that are able to handle a bunch of different requests. And the base handler is able to, in general, talk about the structure of the chain of responsibility. So there's the next handler in the sequence. We have the ability to change which one it goes to. So if you're a worker in a call center, you would say, who is the boss that I contact when I need to escalate a situation? So you have the ability to set that who that boss is, who the next handler is in that sequence. And then we all have the ability to handle that request to the level of authorization that this handler is allowed to work with. So, chain of responsibility. Questions on that? Right. Command. Command turns a request into an object. So instead of having an actual method or a parameter that is that associated request, we have an entire object dedicated to a request. And we can pass that object instantiation around as the associated request. So we're working on a text editor. We want to create a toolbar with a bunch of buttons. There's a button class that can be used for buttons. The buttons look similar, but they're supposed to do different things. What about the click handlers for all of those? So there is an OK button that when clicked confirms, a cancel button that when clicked makes the window go away, an apply button that when clicked doesn't make the window go away, but applies the changes, etc. But the issue, of course, is that there's going to be an associated crazy number of subclasses. And every time we modify the base button class, then we actually have to go modify every single one of those subclasses in some capacity because they're using that functionality of that button. So every time we change the width of the button or something of the sort, unless you are inheriting that from all of the associated buttons, now we have to go change. Is there a text overlap issue in the whatever the longest one of those is, the cancel button? And we find ourselves having to do a lot of copying and pasting of code, which is always not great. So the solution utilizes separation of concerns. We're just going to say, all right, we have a button, a menu item, and a shortcut in the user interface. We're going to have an update that is called between all of that. And what happens when you update a button or update a menu item or update a shortcut? And so we have separation between the user interface and the logic, which is great. In the middle of that, we're going to place a command object whose task it is to interpret the request from the user interface, convert that into a command object, and then the command object is parsed by the business logic. And now there's only one kind of object that's being passed into the business logic instead of all sorts of different kinds of updates, all of which are implemented in the same way. So whenever you recognize that I have a bunch of different UI components that are communicating the exact same thing to the exact same place, that is the place that you would want to put a command object so that everything now passes it to the command object, not worrying about its structure. The save command will create the object out of that and then pass it to the business logic so that the business logic is simplest. So how that works in general, have a command object with an execute, then each of the associated commands beneath it will be able to work however it is that they work and be able to execute in exactly the same way. And when we have a button, then the button allows us to use the same logic for the button because it goes through the command interface rather than each separate command for each separate type of item. So order in a restaurant is very similar. When the waiter approaches you, they take down your order in a way that might represent fields of an object. They're able to pass that object onto the chef, and without any communication between those two entities, the person, the customer at the restaurant and the cook, they're able to interpret what the user wants because it is in a standard format that the waiter is aware of. When the user communicates, however it is that they communicate, I want number 13, or I want the broccoli beef. It doesn't matter which one you state, what they write on the ticket will be the same, regardless of how you say it. And that way that command is the same that is passed on to the cook, and the cook doesn't need to know what the waiter knows, which is the number to dish comparison. It's also easier for the waiter because they have the menu right there. They didn't know, they just look at the menu and then write down the associated whatever it is that they need to write on the ticket. But separation of concerns. That's why we don't communicate this directly to the cook. So we have an invoker and a receiver. The invoker takes a command, is able to set and execute commands based on a command interface and the associated concrete commands that implement the command interface. The client goes through a receiver. The receiver takes in the request for that and then is able to, from there, get the associated command for that option. I like command, one of my favorites. Questions on command? All right, with 2 minutes, we'll get through one we've seen before. Turns out iterator is a design pattern. Where have we seen this before?
Iterator.
Yes, an iterator.
I know I'm gonna keep myself, but I can't think of, I know I've seen it before, I just can't remember where I just.
Anyone who's taken data structures from me should know.
Like a variable or a parameter that's kind of iterated upon, like after a runtime is completed.
Those who've taken it from me, linked lists. We wrote linked list iterators. Why did we have to do that? Why can't you just write a loop that goes through, like a for loop that goes through the elements of a linked list? There's some functionality that's lost when you do that. Yeah, you can't add and remove in the middle as you are looping, because the associated indices change when you do that. Yeah, so imagine that you're iterating through a linked list, you're going from node to node to node to node, and in the middle of that, you want to remove the next node, or remove the current node.
Okay.
What node should you go to next? You just deleted the next pointer for the current node.
What
How do
kind
you
of,
access
what kind of
the
linked
next
list is it? Is it a doubly?
Doesn't matter.
You reference around the one that you deleted to patch the hole.
Yeah, so you have to insert the logic before you delete of where should the next pointer be? I need some temporary variable that's gonna point out what the next node is, so that once I delete it, I can follow that pointer instead of the current node that's been deleted's next pointer, which no longer exists. So yeah, adding and removing in the middle of something like that breaks, and why you can't just use a loop, a regular for loop. If you use a for each loop in Java, that has a built-in iterator. It does it for you.
We use while loops all the time.
Not with linked lists and not with deleting with them. Try it out, you'll get an exception.
We use while loops to output every linked list.
Yeah.
And
But you
then
weren't deleting while you did it,
we were removing data.
but removing the entirety of the node object.
Is the answer recursion?
The answer is just some logic. You need some temporary variable that stores that result in the iterator, but yeah, so, yeah.
Yeah.
We're basically at the end of time already, so I guess we'll come back and refer to this. We have just a few more to go. Hopefully, we'll get to the end of this on Monday.
Chris, and algorithms, recursion's always the answer.
Yes.
Until it's not.
So how do we walk through this tree and replace all the members and child? Recursion.
We're giving you flashbacks.